Well, first of all, thanks to Savripol for inviting me. It's an honor to be here and to speak for all of you. And a big thank you for still being here with me, even though I have the honor to be here as last presenter. It is a long conference, and especially this morning, we have a lot of technical details, so I try to stay out of it. But if you want to go in technical details later on, I invite you to come with me and I will ask and I will answer your questions accordingly. So my role, as explained by Leanne, I'm commercial responsible within Ionica. And since 2 years, we are partnering with Coke Technologies Solutions, which is part of the Coke Engineering Group. And therefore, I'm also, since 2 years, a representative of that partnership, just to make it a little bit more complete. So here I stand, and I'm presenting as the representative of the partnership, the NUA, and I'm going to talk about sustainable plastics, and we need it now. So what are sustainable plastics? I want to take it one level higher. I think, yes, plastic pollution is an issue. But the main topic here is that we need to strive that we are not extracting too much natural resources than what is actually needed. We need to strive to a circular economy. And this was also touched upon by some of the speakers yesterday. So what does circular economy mean? First of all, preserve and enhance natural capital. So basically, minimizing, for example, extraction of fossil resources and plant-based materials. Then when we use these, optimize these resources to the maximum by making sure that we are reusing them, refurbishing, and eventually recycling. And at the end, we're also talking about making sure that we do this production as environmental efficiently. So reducing CO2 impact, water consumption, etc. But where are we now if I just focus on the current situation? And I highlight here one sentence from a McKinsey report. I think if you want to have the report, I can give you the reference to Vincent and he will make it happen. But it's estimated that every year globally, the fast-moving consumer goods basically wastes 80% of 2.6 trillion US dollars, which never be recovered. That's a massive amount of money. And of that value, we throw away, put it in a volume, approximately 350 million metric tons of plastics. So I want you to stand still what that actually means. So I'm going to split it down what that plastic waste means and what also the opportunity is. Because I want to be positive in that sense. So if we just look on how much plastic we throw away. This is a nice data that I got from the OECD, and it's per plastic type. And it's indicating also how easily these types are recyclable. So you can also see what we will find basically as a recyclate. I took the courtesy to look up very high level price indications for the US market for each of these polymers. And then you can see that almost $3 billion US dollars of plastic waste is thrown away. And here I want to capture the upside that we can get. Because people always start laughing to me when I talk about that people are willing to pay more for a sustainable product. Everybody thinks that that's a joke. In my opinion, it's not a joke. What I've seen so far, and I've been analyzing the PET market, and maybe the PET market is a little bit different than the other plastics, is that at the worst case scenario, a green premium of 15% is recovered on top of a virgin price. In the more realistic scenarios, we're talking about 30, 40, 50%. So why does PET have this? I also want to emphasize this, because everybody says, yeah, but you're PET, you're different. Yeah, we're different. And that started all in 2017. 2017, we had a position paper in Europe stating that they wanted to move to legislation of recycled content somewhere in the far future. What happened? 1 year later, recyclates went up in price. 2 years later, they mentioned a year for the recycled content. And from that moment, the rPET price never was below virgin price anymore. So that means that there is power for governments to drive markets to a sustainable business. So, besides the business side and the potential for businesses to contribute on it and have basically a little bit more meat on the bone, there's also a potential for plastic recycling on a more environmental point of view. First of all, by including more recycling methods, whether it's dissolution, as mentioned in earlier talks, whether it's depolymerization, what I'm doing, or pyrolysis, more feedstocks or more waste can be treated. So we can recycle more. That's a good thing. Secondly, we can avoid incineration and landfilling. Also a good thing. Last, and I also want to emphasize here, is that by creating alternative ways to recycle, we can increase the quality of recyclates. That is therefore also easier to recycle after it. And therefore, we can recycle it more and more and more often. And the last point, which I find always a little bit daunting to mention, because it's really depending on calculations with a lot of assumptions, but all of the situations that have been published indicate that we are reducing CO2 emissions in all scenarios. And in this case, I just really want to point out, is this the pointer? Yeah, this is the pointer. This is a very nice bedtime read for those that are interested. It's a publication from CEPS in Europe. And basically what they've done is they mapped the whole chemical recycling landscape and grouped all different analysis and articles on the matter in one, basically, review article. And they indicate in this picture a very nice publication of Lasse. Here we see 5 different bars, and I'm going to focus on the first 4. The first one here is basically the current situation. And if you can see the green here, we have mechanical recycling, and this is basically landfilling and incineration. So if we are just going through the path that we're currently taking, this will be what we are doing. And this will be the amount of metric tons of plastic waste we can treat. So now we move 1 bar next to it. This is a situation where chemical recycling has the preferred option. Again, same amount of metric tons, but we lower the amount of landfilling and incineration. If we then go to a situation where there's mechanical preferred, we go further down. But the most interesting is that when both are used as complementary technologies, we slightly increase currently in the metric tons, and we can further downscale the landfilling than in all other situations. And that is essential. It creates an opportunity to have synergies between technologies. And then there's a very interesting situation here, just to mention, just also for the people here to understand that Europe is not perfect. This is basically a correction of all the data gaps. So everything about double accounting, missing information, also happens in Europe. Just, yeah, you're not the only one. I just want to make sure. But if we are taking account of the virgin production, we think with this, we have the optimum way to move forward. So again, we are not a threat for the mechanical business. We're just one solution for the side stream that they create. So basically, I want to refer to a second report of McKinsey. And here we're talking about investments to go to the packaging and the recycled content. They made a report focusing on plastic packaging materials, and they made a very, very, very hard statement that a global recycled content of 20 to 30% will not be reached by 2030. Why? This. Just by going from 4%, which is current, to 13% globally, requires this amount of work just in infrastructure. It is, at this point, the biggest bottleneck that we have. Creating the infrastructure, opening access to materials will speed up reaching the targets that we want. Whether it's through mechanical or enhanced, we can discuss how much that differs. But this is not for free. So it comes at a price. And I want to show you this picture because it indicates that what we need to do is very dependent on investment and financing. And here I look for this part. Now I'm going to take my own opinion on this. I'm pointing the finger to governments. Creating infrastructure have always been a government effort, whether it's electricity, telephone systems, or railways, or highway. I think, in essence, infrastructure belongs to the government responsibilities. Then, if we talk about the recycling investments, that's different. Here we come more on the private side. Here companies, like here the petrochemical business or the recyclers, should take their responsibilities. And here you see already a big difference. So here is a nice number, small variations, and then you see this bar. So this is not in the McKinsey report. This is the data that I selected from different press releases from different technology providers. Then you ask yourself, why is there such a difference in the investment intensity? That's a good question. I think the answer was already provided by previous speakers, because it has to do with this. It has to do with so many different technologies that are in the space. All those technologies are in a different maturity. And if we just take it back, and I like the presentation of Sassel when they refer to the polyethylene prices. For a lot of the technologies, we're in the 1960s of the polyethylene production, where the price was 4 or 5 times higher than it currently is, because the technology is not mature enough. So the challenge is that people need to invest in something that can scale quickly, but they need to pay to make it happen. So this is a bit, this was already explained in the previous speaker. So let's see what I have. Yeah. So I try to keep it very high level. So how I see the ideal world when it comes to recycling is that we are doing plastic recycling and we have different streams. We have a polyolefin stream, goes to sorters, and then the best stream goes to mechanical recycling, and if it's a bit shitty, it goes to pyrolysis. And if it's having too much PET in it, it goes to somewhere else. Then we have the PET-rich bales. They go all to mechanical recycling. So we can make nice bottles, and then Husky has the solution to make a nice bottle out of it. But people tend to forget that there is a third type of bill. That's basically the bill that nobody wants to have. It's the reject bill. And there's a lot of power. And the power here is, I think it's a returning topic here, it's collaboration. Because my belief is that dealing with reject bills or difficult streams requires collaboration between mechanical recyclers, pyrolysis that go into refining, and our process, so that they can all create and benefit from the synergies. And ideally, this should be located in one location, centralized. So we have per city, big city like Johannesburg, Cape Town, Durban, we have one site that can do everything and then sort locally basically the waste, convert it into a high quality, high value material, and therefore after that you can transport it more easily because the transportation cost on the high value product is less impactful than on a waste product. That being said, I heard a lot of topics here about quality of waste. I am here from a PET point of view. So I'm not going to comment on the polyolefins. But what I've seen so far in South Africa, your PET material in the waste is way better than Europe. So you need to recognize that the system that you have and the applications you have on the market are benefiting a recycling economy. So now I'm going to dive a little bit deeper into the technology and the chemistry maybe, but it's also been touched upon, so I think it's not new for you. But in Europe, we see 3 limitations when we talk about recycling, mechanical recycling. The first of all, downcycling of PET. We can recycle at maximum 6 times. At this point, that's not an issue because it's diluted with virgin quite a lot. So that will only become a factor when we are setting the target of, for example, the 65% recycled content by 2050. Then we have the second one, it's a like for like. I think this is also very applicable for the HDPE guys. So you have a lot of applications, so you need to sort that the material is one application, the same color, same additives, everything needs to be the same because otherwise you screw up your end product. Same for PET. I think I always compare it with my kids doing a painting. They start to color and they take red and then yellow and then green and then blue and then suddenly the whole picture is brown. And that's not what they intended. And then they get disappointed. So I think that's the same here. So we cannot do different colors. We cannot do different materials. It requires a lot of intensive sorting. Then the last one, and I saw also something popping up in the app on decontamination and why not to use a closed loop. Yes, the properties of PET are already nice, but secondly, it's governed in Europe by stating that the material needs to be traceable. And having a material that's traceable to its application requires paperwork, administration, costs, etc., and limits therefore the volumes. So, to dive a little bit deeper into the contaminations that we face, so basically you normally can differentiate 3 things. So there's a mixed fraction, degradation, and the presence of different compounds. So, and I will explain it a little bit in more detail, one by one. Let me see. There we go. Degradation. Basically, the simplest thing is if we are exposing the material for a long time to the environment, it changes based on sunlight, on presence of water, other contaminants that you find in the environment, and that will affect sometimes molecular structure. That's one of the things that you need to take care of and you need to control. Another one is the presence of other compounds. So basically what we have and what you see a lot is still you see a lot in PET. So we have colored bottles. We have nylons still in a lot of the bottles. We have in some regions we have PVC in the bottles. So there's a lot of material included into molecular structure to improve the barrier structures. Then acetaldehyde, which is heavily regulated in the food safety regulations. What is this? What did I do? Everything okay? Yeah? Okay. Oh, you scared me. And then there are, in the essence, there are a lot of material that are used in the process. So you have materials that speed up the polymerization, like catalysts, and you have colorants like titanium oxide that help functionality. And at the end, I think I need to emphasize again how jealous I am on a picker system. Because what happens in the Netherlands or in Europe, you just toss away your packaging, and what happens in your bills, you end up with aluminium cans or with dishwashing bottles, something that's completely different. So what we see is in our streams in Europe, we see a lot of non-PET inerts that we need to remove because they are flaked in really small sizes, sorted out, but every time you sort it, you lose PET. So this is a big, big hurdle for a very completely automated sorting system. So how does this end up then basically in a material flow of Europe? I think I try to make it very simple. What you will see is here is what we produce. So completely on the left, we produce approximately 5 million tons of PET in Europe. Then what we do is we collect PET, which is only 60% of what we have on the market. Then, of that we lose due to the contaminations and the processing losses and the sorters. So basically only 35–40% of recyclate is placed on the market. And here comes the funny thing. A lot of the material, a lot of demand is for the material. So still a lot of the material goes to other applications. And now I think, because it's a returning theme here in the conference, it's the spring box. I know it's unified the whole country, but I keep reminding myself on the first speaker that he was having a springbok tie, and he said, yeah, and it's accompanied with a poly cotton shirt. And that brought shivers down my spine. Because I thought, okay, I understand that you're an economist. You want to have the two for price for one. I understand that. I know it's comfortable, but if you look on a recyclability point of view, it's a nightmare. It goes directly to this space, and it exits the whole circle directly. And that happens for a lot of applications still. And from the things that are remaining in the high quality materials that can be recycled, also only a fraction goes back. So what happens currently in Europe, only 13% is recycled twice. And that is of the material that is stated as the most recyclable plastic that there is. 13%. Just to. So you don't see the effects, the negative effects of mechanical recycling anyhow, because there's so much dilution of virgin. So, are we then not making progress? Yes, we're making progress. I must say, what we see is we are increasing installed capacity for mechanical recycling in Europe, and also the collected volume goes up. But as you can see, still at every time we lose 25% of the waste of input and output material. It's all sorting losses. But is this enough? Is this trend of a year-on-year growth of 13% good enough? If we want to make a target of 2025, we need 1 million metric tons additional recyclate on the market. That's a lot. It's very difficult, very difficult. And if we want to make the target of 90% of the PET bottles being recycled by 2030, we need to increase the installed capacity with 1/3. That's also a lot of money to make that work. And then when we are there and all bottles are recycled, only the 25% recycled content in the bottles can be obtained when we are basically shifting away from the other markets. So that is what we do. I will then very briefly touch upon this because it was very high in the McKinsey presentation. Some interesting points that I want to mention here. US. The interesting bit is that since this year, the PET industry is joining a lobby to harmonize basically the bottle bill or the EPR schemes, which is a massive impact. India was not emphasized that much in the McKinsey, but they implemented a 30% rPET content mandate for 2025. And recycle 60 to 80% of all plastics in 2028. So that is basically creating a demand of 0.4 million metric tons of recycled PET and replacing therefore 2% of the global PET production. So you see that the power there is within legislation. So I wish that the government will also hear this story. There is power in the government to make progress on a circular economy. So this is the technology. I don't know how much you already know on the different technologies, but I try to save it a little bit for outside because I see I'm over time. So if you want to know more on the different depolymerization process of PET, please address me outside. Happy to answer all the questions. But the interesting bit is this. This is one of the slides that I really want to mention is, yes, I'm very proud that our glycolysis process is generally thought of the most sustainable, but that's not the reason why I popped this slide up. This is a picture of Bloomberg, where they take 3 different models to calculate CO2 emissions. And what you see, if I just take virgin production and glycolysis, the reductions change from 40 to 60%. So therefore, it makes very much sense to harmonize how we are going to evaluate technologies like this. In essence, we believe that we are quite conservative in our approach. So we have the least one that's contributing. But if we would take, let's say, a more aggressive approach, we could stay, instead of 50, we could say 75% lower carbon footprint. So that is something that I really want to give you as a key takeaway. We, as industry, have a responsibility. The different technologies create synergies, but we need to make sure that legislation creates the transparency so that we can make the right decisions and selections on where to move forward. That was it, because I'm over time.